In this example, we're going to acquire some data from a serial RS232 communications link and then use the serial decode tools to decode the ASCII characters transmitted. The setup is a two-channel setup, so on channel A we have connected to the transmit line of an RS232 pair, and channel B has been connected to the receive line of an RS232 communication pair. So I'm going to change the trigger condition to single trigger and then arm the trigger condition. So this is now waiting for some data to be transmitted, and now we see some transmitted data. So on channel A we had the trigger and we acquired a transmitted burst of data, and then sometime later on channel B a received data packet appeared. This is in fact a communications link to an instrument, and this is a control from a computer. So at this point we can go ahead and set up the decode tool. So under the tools I'm going to select serial decode, and here we can see the channels A and B which are turned on. So again, both channels are going to be RS232, so that's going to be for the transmitted link, and channel B is going to be for the received link. In fact, this is an example where we can use the channels to decode any buses at the same time. So now we have to set up each channel. So for channel A, the threshold is 0, which is correct. The baud rate is 9.6 kilobaud, which is correct. Obviously this could have been changed. And in the settings we can set up information about a particular link, whether the idle is high or low, the number of bytes of data, 5, 6, 7 or 8, whether there's any parity bits, how many stop bits, 1 or 2, and what order the data was sent in. So that must be set for the correct decoding. And similarly on channel B we set up the threshold and the baud rate. The data can be viewed in the view menu or into a separate window, so I'm going to turn on separate windows for the two acquisitions. So now here straight away we can see the decoding window A and B. So this is channel A, so this is the packet of data that's been acquired, and here we can see the data bytes in hex. So I'm going to change those to a ASCII format, and then we can read those in ASCII, and similarly with the B, this is in hex, so I'm going to change the B view similarly to ASCII. So now we can go and have a look at the command. So here we can see the command set out. So the command that went out was channel 1 impedance query. So the controller was asking the impedance of the instrument, and then we can see the reply has come back 50. So it has returned that it's obviously in a 50 ohm format. Finally, I'm just going to increase the record length to show how we could actually capture more packets. So I'm going to increase the length to 100 milliseconds and then arm the trigger. So again, we're waiting for a data transmission. So here we can see a transmission again, and we can see that a repeat transmission was sent out sometime later. So we could either measure this with cursors, or we can look into the recorded data. So just to measure it with a cursor, we can see the first transmission went there, and put a second cursor when the second transmission went out. So the time between the two transmissions was 802 milliseconds. And we could see the similar information here because we can see the packet time. So here we can see the first command going out, so we can see channel 1 impedance query, and that the last bit of that went out in 15 milliseconds, and then some 802 milliseconds later the second transmission occurred. So we can use the decoded data to do any time calculations on transmissions.